Okay, let's do some adding and subtracting of fraction problems. They're just a little bit harder. Just add an extra little twist to it. Okay? We're going to that involve mixed numbers now. Okay, numbers that mix a whole number with a fractional part to it. Okay, we're going to add the fraction parts, and then we're going to add the whole number parts. Okay, so let's say this was a problem 3/4 minus 1/4. The denominators are the same. 3/4 minus 1/4 is 2/4. And then the whole number is 5 minus 3 is 2. Okay, so I get 2 and 2/4. I've got to reduce the fractional part here. That becomes 2 and 1/2. Okay, so that's a little harder. I added a mixed number to it. What if the denominators are not the same? Okay, what if I had something, and I'll make this an addition problem. What if I had 4 and 1/4 plus 2 and 1/2? Well, again, you could do this really just mentally thinking of money. 4 and 1/4 plus $2.50 is going to be $6.75. Okay, so if you get that answer, you know you're right. How do we do this? Well, again, the denominators here are not alike, so we have to find equal fractions with common denominators. I'm going to bring the 4 over and the 2 over, put a fraction bar. If I count by 4s, I get 4, 8, 12. If I count by 2s, I get 2, 4. Well, there's my common denominator. I came upon it already. So 4 is going to work for a common denominator. 2 changes into a 4. 2 goes into 4 twice, so I'm multiplying by 2. 1 times 2 is 2. I change the 1/2 to 2/4. 1/4 stays 1/4. So I've changed these just like we did before to equal fractions with common denominators. 1/4 plus 2/4 is 3/4. 4 plus 2 is 6. There's your answer that we knew for money was $6.75. $6.75. Okay, little different one. Let me do now. Okay, working with mixed numbers again, we're going to look at this one, okay? 5 and 1/2 plus 3 and 1/2. Okay, well we could probably do this in our head. 1/2 plus 1/2 is 2/2, okay? 5 plus 3 is 8. Well, 2/2 is just equal to 1, okay? 2/2 equals 1. 3/3 equals 1, 4/4 equals 1, okay? That's a handy fact to have. So what do we get here? This we know is really 8 and 2/2, which is really 8 and 1/2, okay? Which is really 9, okay? So we would change that answer 8 and 2/2 to 9. Okay, let's look at something just a little bit different. What if we had this one, 4 and 2/4 plus 3 and 3/4, okay? Well, the fractions have the same denominator. 2/4 plus 3/4 is just going to be 5/4. 4 plus 3 is 7. So I have 7 and 5/4. Well, if you have 5/4, that's really $1.25, isn't it? Okay, this really turns out to be $1.25. $1.25. Okay. If I add that to 7, I'll have $8.25 left over. Okay. How do we change this fraction, 5/4 or 5/4, to a mixed number? This is called an improper fraction because the top number is larger than the bottom number. We know it's going to be more than 1. There's a little method we could use to do that. If we have 5/4, we could think this. We could think, well, that's the same as 4/4 plus 1/4, okay, which is the same as 1 and 1/2. Or we could divide it out. Okay, we could say, well, let's divide this out. Anytime you have a fraction, you can always divide it out. 5 over 4. This fraction bar always tells you divided by. So 5 over 4 is 5 divided by 4. That would look like this. 5 divided by 4, or it would look like this, 5 divided by 4. Okay? If I do that little problem, 4 goes into 5 one time. 1 times 4 is 4. I subtract, I get 1 for remainder. And remember, one of the things that we can do with the remainder is turn it into a fraction by putting it over this number. So that is 1 and 1/4, okay? So that 5/4 that goes along with a 7 is really 1 and 1/4. Sometimes you can figure it out just by thinking about money. Sometimes you can figure it out this way, okay? And sometimes you can just divide that fraction out, realize that that fraction is equal to 1 and 1/4, add that to the 7 that you had, and you get 8 and 1/4. Okay, let's move on. Okay, here's a little bit more difficult subtraction problem, okay, using mixed numbers. What if we had this one, 5 minus 1 and 1/4? Okay? Well, there's nothing to subtract the 1/4 from. But again, let's just think money. If you had $5, okay, $5, I could write like this, minus $1.25, $1.25, okay, you could subtract, that would become a 4 and a 10 and a 9, and a 10 minus 5 is 5, 9 minus 2 is 7, 4 minus 1 is... Well, the answer would be $3.75. We know that 75 cents, it would be 3/4, okay? So we know that this would be the same as 3 3/4, okay? So that's one way to figure it out, but that doesn't work, you know, if it's not easily changed into money. So let's see what we do here. This is where we have to do some borrowing, okay? Just like in this problem, we didn't have any coins over here. We didn't have any change on this side, so we borrowed $1, okay, from the 5, and we made some change over here so we could subtract the 1/4. Well, what we do here is we say, well, I've got $5 and I've got to subtract 1 and 1/4. I'm going to have to take one of those dollars into a bank or something and change it. So now I only have 4 whole dollars. And how much change am I going to get for that $1? And I want it in quarters because that's what I'm going to be subtracting. Well, I'm sending over here actually 4/4, okay? So this is a little operation I did. 5 changes into 4 and 4/4, which is the same as 5, but now I have some quarters here. Okay? So you just choose the denominator, the same denominator that you're trying to subtract, the number on the bottom, and you're going to take a full amount of those. Okay? You're going to take 4/4. If this were fifths, we'd get 5/5, or 6/6, or 7/7. Okay? Now 4/4 minus 1/4 is 3/4. 4 minus 1 is 3, and there's our answer again, 3 3/4. Let me make it just a little bit more difficult here. What if we had a problem like this? Okay. What if we had $6 and 1/4? Okay, and I'm using money here because it's easy to visualize it. Minus $2 and 3/4. Okay, well, same situation. I don't have enough quarters up here. I don't have enough fourths up there. I've got to subtract 3. I've got to give you 3/4, and I only have 1, so I've got to make change again here, okay? The bottom number is going to stay the same. The 6 is going to become a 5. I've got to borrow $1 from the 6. So now I've got 5 left. And how many quarters do I get for that $1? Well, I get 4/4, right? Because that's a whole dollar. Plus, I had this 1/4 over here, so now I have 4 plus, now I have 5/4, okay? So $6 and 1/4 is the same as $5 and 5/4. Little borrowing, okay? Now we can just subtract. 5 minus 3 is 2. 2/4. 5 minus 2 is 3. That's 3 2/4. Again, we're going to reduce to 3 1/2, okay? Could you have done this just thinking about money? You could have. You could have said, well, I have $6 and 1/4, that's $6.25, and I'm going to subtract $2 and 3/4. 3/4 is 75 cents. Okay, 5 minus 5 is 0. We're going to bring this decimal point down. The 2 needs to have some more value here. We're going to change the 5 to a 6 to a 5, make that a 12. 12 minus 7 is 5, okay? 5 minus 2 is 3. Again, we get $3.50, same as $3.50, okay? Okay, one more thing about fractions and mixed numbers. Just like we took 5 quarters and we changed that into a mixed number by dividing it out, remember that? That's 5 divided by 4. 4 goes into 5 once, and we get 1 quarter. What if we had 1 1/4, and we wanted to change that back into an improper fraction, okay? Well, again, we can think, well, I've got quarters here. I know that 1 is equal to 4 quarters, okay, plus the 1 quarter that I had, so that could be changed back into 5 quarters, okay? The way we usually do it, we'll just say 4 times 1 is 4, plus 1 is 5, and it's quarters, okay? If I had 2 1/2, okay, I would go 2 times 2 is 4, plus 1, that's the same as 5 over 2. $2.50 is the same as 5 half dollars, okay? This comes in handy sometimes also.